As we're getting Tim up on the stage, I just am going to remind you all to jot down the questions if you have them, and we'll be moving into the Q&A segment just after this, so don't be shy. Welcome, Tim.
Good evening. Can you hear me? My name is Tim Hebrink. I've been doing research and product development at 3M for 30 years, and it's my pleasure to share with you some amazing technologies that can improve your building energy efficiency and create the green buildings of the future. But first, I'd like to explain some of the reasons why 3M has been so successful at innovation over the years, and some of the core elements that help drive the process of innovation at 3M. So this is the 3M periodic table of core technology platforms, and it is intended to impress you with the breadth of technologies that 3M has. There are world-class experts at 3M within each and every one of these technologies. So necessity is still the mother of invention, but just think if you had a toolbox of 46 core technologies that would help you enable those inventions. 3M is famous for its 15% time, which is time that has allowed 3Mers to work on their own ideas. Freedom to work on your own ideas is really motivating and rewarding. What some people don't know is that 3M has many internal conferences, some of them like this, where people share their ideas with others. And that's where a lot of the uncommon connections occur, is in sharing those ideas. And in addition to the breadth and depth of technologies at 3M, it's really people that are passionate about their ideas that makes 3M successful. People that share their ideas, and people that work well in teams that make innovation happen. Some of the product ideas come from 3M interviewing customers and learning about their unmet needs. Some of these are not really explicitly articulated needs, but these are what we call customer-inspired innovations. And the first example of a customer-inspired innovation is 3M masking tape. When Richard Drew observed some people painting cars in the old days. So this is a problem that needs to be solved, and it can be solved with innovation. 35% of the energy used worldwide is used by buildings. One way to address this, or the easiest way to address this, is to keep buildings from losing energy. Some of 3M's oldest technologies, tapes and adhesives, can be used to reduce building energy loss. Product developers at 3M have modified and improved wide format tapes so that they can adhere to the non-uniform surface structures on buildings and conform to their shapes. These tapes expand and contract as the building expands and contracts, so that it maintains an airtight seal. The adhesive means you don't need to use nails or staples to attach this airtight membrane. And if you do put a hole through it with a nail, it's self-healing. It seals up around the nail and maintains the airtight seal. So this is a common form of innovation at 3M, where you take an existing product and you improve it to solve an unmet need. Inspired by nature, this amazing technology is being used in many ways to improve energy efficiency. We have made multi-layer optical structures just like you can find in the wings of butterflies, the feathers of birds, and the scales of fish. And we've mimicked nature by co-extruding hundreds of layers of two different polymers together, high refractive index, low refractive index polymers. And we can tune those layer thicknesses to reflect any wavelength of light. We can reflect UV light, or visible light, or infrared energy. And this technology was actually acquired from another company. We purchased 10 of their patents, but that company never had a successful product. The technology needed improving, and 3M improved the technology and made connections with more useful applications, and it has made 3M hundreds of millions of dollars in multiple ways. So 3M's significant advancement in this technology is in using birefringent polymers to increase the reflectivity of these multi-layer films and manage the way that the incident light reflectivity is reflected off of them. So infrared mirrors were one of the technologies that we acquired with these patent purchases. But again, that company never made a film that was good enough quality to put on a window. But 3M just happened to already be in the window film business. So we combined our window film expertise with this new multi-layer optical film technology, and we were able to reflect infrared energy and reduce your air conditioning costs. I like to call this the invisible mirror because you can't see it. Visible light passes through it, but the infrared energy is reflected in it. A little tip for you, if you want to get more power out of a solar thermal panel or even a photovoltaic module, put it down here below your window with this infrared mirror on it. By business success, this has been our most successful multi-layer optical film. Reflective polarizers increase the energy efficiency of liquid crystal displays by 50%. And this can be used to either make the display brighter or reduce energy consumption in the display. All liquid crystal displays have two absorbing polarizers that are crossed. And if you don't use our reflective polarizer, half the light from that display is absorbed by that bottom absorbing polarizer. Many of you have smartphones, laptops, and large LCD TVs at home, and it has this film in it and you didn't even know it. This innovation came about when a 3M scientist was working in a lab developing an alternative reflective polarizer technology. And he was struggling, and he went to one of these 3M internal conferences, and he learned about the multi-layer optical film technology. And that is one of those uncommon connections occurred that enabled a huge business for 3M. Another very effective way to save energy in your home is to bring more natural light in, and this is actually good for your health. Many studies have shown that people are more productive when working under natural light conditions. 3M makes the most reflective film in the world, and that's especially important when you have a light guide duct that has multiple bounces where the light has to bounce multiple times going through that duct. So you can bring the energy further into your home. This shows what a 99% reflective mirror film, how much light it can bring in compared to a 90% aluminum mirror. This invention occurred when a 3M scientist went to a lighting conference and met somebody that was selling aluminum reflective light ducts to bring natural light into a home. This is 3M's most recent daylighting innovation, and it brings additional natural light in through refractive optics. It carries it further into the room, and it creates less glare on desktops, which causes eye fatigue. This is my favorite 3M technology. 3M has been doing more innovations in photovoltaics. It is what we call cool mirror film, and it increases the peak photovoltaic power output of modules by 50%. And it not only looks cool, but it is cool because it puts this additional sunlight onto a panel without overheating it. It transmits far infrared energy, and that reduces the overheating of the panel. So this is a nice photo of a 10K solar photovoltaic array on a nearby Minneapolis rooftop. This is our cool mirror film. And it is especially effective in northern climates like this or anywhere that modules are used further than 20 degrees latitude from the equator, because the modules are almost always tilted to maximize their exposure to the sun. When you tilt the modules, you create a space that you might as well use a mirror that gets more sunlight onto the module and allows them to produce more power. But besides this beautiful photovoltaic array, what impresses me about this photo is all this surface area. I see buildings of the future having skins on these buildings that have state-of-the-art insulation integrated with translucent materials that allow daylighting, but at the same time collect solar energy and store that energy. And then it's all tied together with the smart energy management systems that you heard about earlier tonight to enable you to have a self-sufficient building that is basically net zero energy usage. Okay.
Fantastic. Let's have another just round of applause for all those 5 fantastic presentations. And I'll invite the presenters and the moderator of our next section to come up and join us on the stage for the Q&A portion. So while they're getting settled, I just want to say, all of us here in the audience are experts at this. We all have our particular expertise. So here's a chance to hear from you. Like I mentioned, jot questions down. There's cards and pens under your chairs. And then we have some folks who will be circulating, Helen and Emma in the back, and you can flag them down and hand their cards off. I want to introduce our moderator for the Q&A portion, who's Kevin Bankston, who's a project manager at CEE. And Kevin is no stranger to using technology for advanced applications. He's heading up the Energy Intelligence Program, which we've mentioned, giving data and feedback to small industrial customers. So I'll let you take it away, Kevin, and for the Q&A portion.
All right. Thanks, Jenny. While we're getting settled here, I just want to reintroduce the panel. We have Steve Nadell from ACEEE, Mark Brown from MyMeter, Rich Sidlowski from CEE, Tim Hebrink from 3M, and Jay Stein from eSource. Thank you for joining me. I'm amazed. The future of energy efficiency in Minnesota looks really exciting indeed. And really, I want to know, when can we start and how much is all this going to cost? Help me out here. But, we covered a lot of technologies and concepts in these last few presentations. We talked about smart buildings, data, internet, feedback programs, technology, reflective materials with daylighting. But really, what I want to know is there a specific technology or concept out there, or maybe it's technologies, that will be more relevant to Minnesota, either at the building level or at the grid level? And where should we be going? What is the next big thing for Minnesota? So if share your thoughts. Yeah.
Let me take a stab at this first. And actually, I should preface this by noting that most of what I know about Minnesota I've learned by watching Coen Brother movies. But and I didn't even talk about this in my talk, but some of the things that I think are important right now when you're thinking about energy in Minnesota are for one thing, it gets cold here. It wasn't cold this week, but from watching Fargo, I know that it does. The electric utilities burn a lot of coal, and so with the upcoming EPA regs on coal plants, I know the state's going to be looking for lots of efficiency offsets because it's going to be tough to meet those new regs solely by shutting down coal plants. And so, and also too, I know that Minnesota is actually a pretty good data center market. Not one of the biggest ones, but it's a pretty good one. So places I think that, given all that, places I think that are especially worth looking into would be heat pumping. So ways to get more energy out of the electricity that's used for space heating. Or in other words, use electricity way more effectively for space heating. With heat pumping, I've seen lots of electric resistance heating systems while I've been here in Minnesota, and heat pumping could easily cut the energy consumption of those by 2 or 3 times. So I think that's a fabulous opportunity. I also think that information technology is a big opportunity as well for Minnesota.
Great. Thanks, Jay. Any others?
I see insulation is always your quickest way to get a return on your investment, and windows have 1/10 the insulation value of your walls, so there is a tremendous opportunity to improve the insulating of your windows, and windows are becoming more popular. And so I think a photovoltaic integrated window blind that also has insulation, maybe thinsulate, could be a very effective way to provide energy efficiency and energy generation from your buildings.
Thanks, Tim.
I just add, all of us talked in some way about intelligent efficiency. A lot more has been done on the electric side than the gas side. I think there'd be a lot of opportunity to apply this more on the gas side, particularly given how much gas is used for heating here in Minnesota.
I can do a follow-up here, too. We have a question in from the audience that touches on the intelligent efficiency and the smart building controls. We discuss electricity reliability in our field frequently, but many of the technologies discussed tonight require reliable communications or reliable communication networks. Is there any concern about how well these technologies will work with our communication networks?
Yeah, I can touch on that a little bit as we see it in terms of, we deal with a lot of the infrastructure for smart metering, and a big part of that is the ability to bring that information, back, whether it's through RF mesh network, power line carrier networks, cellular networks in some cases, and it does create a lot of challenges for the utilities to deal with. Do they have the bandwidth to bring back that much information? And so, in some cases, they're having to limit the amount of information they can bring back. And we do a lot of work with utilities in terms of IT integration. Just the idea of innovation for utilities is worth touching on, that they don't spend a whole lot of money on research and development. And in many ways, I think a lot of the smart grid innovation is a little bit of the tail wagging the dog, and a lot of utilities are kind of, in some ways, pulling back and not wanting to be the first to try to go somewhere. And so I think helping have tools to solve some of those integration challenges, to help them maximize what their infrastructure will allow to them to realize in terms of those intelligent systems is key.
But these reliable communication networks, that is something that needs to be developed. It is an issue. You've run into it in your field experience, and it's just something that still is under development and needs to be worked. I mean, how far along are we, at least with metering, with your experience?
In terms of the adoption of the technology, I think it's been a while. FERC had a study out that it was, and it does vary dramatically by region, the degree to which we've penetrated AMI infrastructure throughout our, at least on the electric side, it's somewhere in the neighborhood of 40 to 50% of the endpoints. But you have states like Florida, California, Texas that are much more widely penetrated. Here in Minnesota, we've seen a lot of adoption, like I said, for some of the rural electric co-ops, and a little less initiative from some of the investor-owned utilities to go all the way there. So it does vary.
Just to add a comment, yes, communications networks are not fully reliable. We've gotten better. Cell phones are much more reliable now than when they first came out. That said, we need to plan for that. I think a key is going to be, when the communications go down, the devices still need to be able to operate. They don't crash. They just continue to operate in their own native mode. When they can reconnect, then they can start broadcasting, but really try to design it so it doesn't crash.
Great, thanks, Steve. We have another question from the audience here about microgrids. No one specifically mentioned microgrids. What role would they play, or could they play in Minnesota, I guess? How would you define the microgrid's benefits to future technology, to technology in Minnesota, to energy efficiency? Does anyone want to take on microgrids?
Nobody wants this one? Okay, I'll talk about microgrids. Microgrids, they got a tough row to hoe, actually, because right now you want inexpensive, reliable electric power. All it takes right now is you hook a wire up to a building. So there's some fabulous markets. There's some fabulous markets for microgrids, especially outside the areas of existing transmission and distribution in the rural third world. But I'm not seeing right now, with the exception of solar electric systems or places where there's tons of subsidies, I'm not seeing the microgrids really making huge inroads. And so I think for microgrids, so it's an exciting idea, but I think for them to show that they're really going to be a huge contributor, they're going to have, it's up to them to prove that they can really provide lots of benefits at a low cost compared to utility systems. And I'm not seeing that outside of niche markets yet, but I'd be delighted if somebody here could show those to me, because I'd be happy to see how that'd work.
Thanks, Jay. I'm gonna get back to maybe a little bit about the concept of smart buildings here. And we talked about the mobile devices, we talked about the internet. You know, you look at another utility system, the telecom industry or wires industry, mobile devices like smartphones really transformed that industry. You know, they were a traditional regulated monopoly, and it really transformed that industry into a service-driven industry. And I guess, do you see smart buildings or these concepts around it being a technology that utilities would grasp onto as, say, an optional service offering to help prevent them from going into this so-called death spiral? Is that a possible next step for utilities, or what could some of the next steps be to avoid this death spiral?
I mean, one, I don't think there will be a death spiral, as opposed to not quite the sales growth that they've become used to. Yes, they need to think about additional services, but they need to think about services where they are expert. I suspect smart building, there's so many venture capital funded new startups going on. It's going to be hard for the utilities to compete with that, as opposed to how to leverage that help to help their customers find the best service providers for them. How to, maybe, I know he was talking, C was talking about how you can do performance-based incentives based on actual savings. These service providers can provide those savings through smart buildings. Utilities help enable it, things like that. That'd be my take.
There was actually a consultant that was here tonight I was talking to earlier, and the comment he made is some of the poorest operating buildings he's seen are some of the newer buildings with some of the smartest control technologies, and I think there's always going to be that human control system interaction, and you have to have people that are able to monitor those set points to optimize those systems, and I think that may be a role where utilities can help provide the technical assistance, the support resources. So, as you have turnover in the personnel that may be involved in building operations, there's an opportunity to optimize the performance of the buildings. And I think you do see that with certain programs, remote-based commissioning, et cetera.
I think a lot of the work that we've done at CEE looks at those kinds of issues, the building recommissioning activities, where what we find is a lot of buildings have a lot of equipment and data systems and smarts in them, but it's up to the people to actually program it and get them to work correctly. And so that is an ongoing downside of any of the information systems, because as it gets more complicated, it's also more complicated to maintain, but certainly doable. So I think it's just another one of the issues that we have to address in the long-term growth of that program.
One thing that you really need to take advantage of natural daylighting is simple light sensors that tell the lights to turn off when natural daylighting is available. I see so many people with windows, nice sunshine coming through the windows in their office, and they look up and their lights are on.
Okay.
I don't really have anything to add to this.
All right. We hit that one pretty good. Good. In some of the presentations we talked about changing, well, let's just say like changing lighting strategies or possibly changing cooling strategies, and maybe using task lighting a little bit more while ambient levels are dim. But so I think this question kind of gets at, can you embrace energy efficiency without sacrificing lifestyle? Because I think what this question is getting at is that in the past we've just upgraded the efficiency of the equipment and kept the output the same, but now we're talking about really changing how that equipment operates and crowdsourcing apps, telling them whether you're hot or cold and having everyone vote on it or whatnot. I mean, can we do this, and can we do it at a reasonable cost? So can we implement these things without sacrificing lifestyle?
Well, I don't think they're going to happen if they sacrifice lifestyle. I think that was the entire point I wanted to make was that these smarter technologies are going to be better at delivering to us the energy efficiency, the energy services we want, the amenities we want. And by doing so, they'll save energy without us really even noticing it. I think we could ask people to make sacrifices to save energy, but I think that's going to work about as well as all the things that we ask people to make sacrifices to do that they sometimes choose not to. So anyway, that's the way I see it. You guys got anything to add to that? Steve, you want to chime in here?
Yes, about a year and a half ago, we did a study looking at efficiency opportunities out to 2050, try to get our crystal ball like Jay showed in his slide. What we found then, and obviously this is not super precise looking that far out, was we found an opportunity for about 40% energy savings from technology-based things. How can you better controls, better heat exchangers, et cetera, et cetera, et cetera. Then there was an additional 20% savings, which involved some lifestyle changes, things like greater use of multifamily housing, people living less far out, way off into the exurbs, changes in transportation patterns. So you can debate whether those are sacrifices, particularly I have a daughter in her 20s, her generation so far is liking those things. Will we move in those directions and capture that extra 20% savings, or will we say, no, we just want our current lifestyles and we want the 40%? But rough numbers, that's what we're finding.
Thank you, Steve.
And certainly the 20%, I think, can all be done without sacrificing. It's a matter of, more than anything else, turning things off when you don't need them. If you're not in the room, if you're not in the building, let the building know that and have it automatically shut down the services and restart them before you come back, and you never know that they weren't on. So it can work very well.
Great, thanks. I think I have a semi-serious question here. I'm going to read it. Do any of you have an embarrassing story to tell about Sheldon Strong? We're gonna move along, though, I think, and wrap this up because we are at our time limit. Well, yeah. All right. Well, we've had great presentations about future technologies to help us with our energy efficiency efforts in Minnesota and to help keep Minnesota a leader for the next 35 years. However, before we go tonight, we are going to ask our panelists one more question, and we're going to have a little bit of fun with it. We're going to do it in the spirit of the radio show, Wait, Don't Tell Me. So, panel, I want you to put on your futurist hat and think to the year 2062. That's the year that the Jetsons cartoon took place. And tell us, what types of energy use problems or solutions will the Jetson family run into as they take actions to lower their energy usage? And so as you think about that, I'm going to turn it over to Jenny to say a few closing words.
Thank you. I can't believe you didn't want them to tell embarrassing Sheldon stories. I want to just give another great thanks for all of you for being here, and a round of applause to the CE staff that helped with this fantastically. Anna, Helen, Emma, Brian, Lester. I want Megan to come up here and join me because she deserves a really big round of applause for putting this night together. She did a fantastic job. Thank you, Megan. Thanks again to Mac Fail. This has been great. And thank you to our sponsors, NRG, Midwest Energy News, and the U.S. Green Building Council. So with that,
Now,
panel.
In the year 2062, what types of energy use problems or solutions will the Jetson family run into as they take actions to lower their energy use? Steve.
Okay, if people remember 2001: A Space Odyssey and HAL the computer, well, by 2062, HAL is going to be your home energy management system. And I think HAL may interfere a little too much and be a little too argumentative with the Jetsons' taste.
Very good.
So I have a cheat sheet from our hosts here. Mr. Spacely is strongly considering certifying the newest ISO standard, 10,000,001, to help his business, Spacely Space Sprockets, remain viable in the highly competitive space sprocket manufacturing segment. And to that, I will just add rhubarb.
Astro the dog, he had to get his exercise. He still has to get his exercise in the future. But the nice thing is that in situationally aware buildings, when Astro gets on the treadmill, it automatically turns on. Nobody has to turn it on for him, so he's ready to go.
Excellent.
Ah, shoot, you stole mine. I was going to say that there is a Siri-like or a HAL-like voice overhead that says, Jetson, your space scooter battery is low. You must get on the treadmill and charge it back up.
Because the Jetsons actually is more about the present than the future, I predict that George Jetson is going to really struggle to find an energy-efficient set-top box to run his 205-inch organic LED hologram projector.
And if any of that happens, panel, you'll hear about it at the next technology forum. Thank you very much. Thank you.